Hi everyone, good afternoon. Really excited for today's lecture. Today we'll be talking about the Agentic framework. So, what exactly is the Agentic framework? It's a methodology for designing AI systems that act as intelligent agents, capable of autonomy, alignment, and accountability. So, remember those three A's kasi babalikan pa po natin yan mamaya. And I guess before we get started, let's do a brief overview first on what an AI agent is. And I feel like this would be a really good segue into all of the lessons that we've learned and that we've taken up. Kung titingnan natin, we started by understanding what exactly is NLP, what are LLMs, and how does AI kind of bring all of these things together. Then we started looking into fine tuning. After looking into fine tuning, we quickly started discussing a RAG, and you were able to build your own RAG chatbot and then integrate AI personas into that. And last week, we talked about natural language generation. So now, looking at AI agents, what does it mean? So, in this context, an AI agent refers to a system designed to operate independently in its environment, and it can make decisions and take actions to achieve a specific goal. So, kunyari, like yung nakita natin nung una, unlike traditional systems, agentic AI doesn't just follow predefined instructions, so hindi siya more on rule-based. So, it perceives its environment, it processes information, and is able to act intelligently. So, why does that matter, and why is it cool that we're learning about this, especially today? So it's relevant because AI systems are integrated into a lot of high stakes domains like, for example, healthcare, transportation, finance, or even as we saw in last week's topic, for businesses and founders, VCs, and even logistics. Right? So these systems often make or assist with decisions that can significantly impact lives. And yung agentic framework na gagamitin natin today, it basically will provide a structured approach to ensure that AI systems are effective, ethical, and aligned with user expectations. So in the code demo today, we'll actually be looking at something that is newly released. Siguro mga 1 month pa lang siya. I think it was released sometime in October. So we'll be looking at Swarm by OpenAI. Great. So before diving into that, let's discuss a bit more yung overview ng agentic framework. So as mentioned earlier, it's basically a structured methodology for designing AI systems as autonomous agents, right? So madami kang agents, how do you put those agents together, right? Or how do you allow your swarm of agents to kind of work together? So these agents have the ability to perceive, to reason, to act, to learn, and to operate within supposedly ethical constraints, right? So why is this important? This is important because AI systems are becoming integral to critical infrastructures, right? So kunyari, kung titignan nyo yung healthcare, one way that we can see AI and agentic work here is when AI can recommend treatments based on patient data. Sa finance, AI can help us make decisions about loan approvals and investment strategies. Even in autonomous vehicles, AI can help control navigation and safety mechanisms, right? So these applications demand a high level of reliability and alignment with ethical concerns and societal norms. And actually, you can even break down all of these different functions and processes into an agent, right? So this framework differs from traditional approaches because we're not just addressing functionality, but we're also looking at the interaction of AI with human systems. Right? So how can we ensure that systems are designed to minimize risks, to align with our values? So hindi lang in-optimize yung certain goal, but doing it the way that we would want as well, and then remaining adaptable across diverse applications. So I think like as you work on your AI agentic frameworks and your projects for this week, also start to think about not just the efficiency or the technicalities, but also how do you consider fairness, transparency, and potential social impact as well. Great. So now that we've covered what the agentic framework is, let's look more closely on the principles that it's built on. So it's built on three core principles, namely autonomy, alignment, and responsibility. So the first principle, autonomy, this one refers to an AI system's ability to operate independently without requiring constant human oversight. So pagka sinabi ko yon, this doesn't mean na wala tayong constraint for the system. It just means that we can make decisions or the AI can make decisions and take actions within defined boundaries. So boundaries that we as engineers will be the ones to set as well. And later during our live coding, we'll actually see how those boundaries work. So, what's a concrete example of this? Think about autonomous vehicles, for example. So, these autonomous vehicles and their systems, they use sensors, cameras, LiDAR to perceive the environment around them and to make real time navigation decisions like avoiding obstacles or changing lanes, right? But this autonomy is bounded. It must prioritize safety and adhere to traffic laws. So just because we want to get to a place doesn't mean na sasagasaan natin yung mga pedestrians, right? So there's still that sense of boundaries, defined boundaries that we define as engineers as well. The second core principle that we have here is alignment. Alignment naman, this ensures that an AI agent's behavior aligns with its intended goals and the values of its developers and users. Right? So misalignment can lead to harmful or unintended outcomes. So for example, you can have a recommender system optimized solely for engagement. However, this might start promoting clickbait or misinformation because it wasn't designed to balance engagement with the quality of truthfulness. Diba? So I forgot that name of the movie on Netflix, right? But it basically talks about how a lot of social media is designed to maximize your screen time on a certain website. But we need to ensure that we have ethics and alignment in that sense as well. Right. So, dito papasok yung pinag-usapan natin on the first day of the course where we also had a talk by Doc Ligot on AI ethics. The third core principle is responsibility. So, responsibility ensures that AI systems are auditable and accountable for their actions. So, this means that the system must have mechanisms to explain its decisions and allow humans to trace any potential errors or unintended outcomes. So, this is really important, especially because, sometimes, and I know you probably read online about yung mga unintended consequences of AI, right? And why, for example, we might need human in the loop or just having an additional check to make sure that the AI is performing the way that we intended to, the way that we wanted to, right? So, for instance, in predictive policing, an AI system must be able to explain why it flagged a particular individual or area as high risk. So, this is especially important then kapag meron kayong mga computer vision applications, so on and so forth, and you're using like facial recognition or facial imagery. So, just making sure that we have that accountability and it is auditable as well. So these three principles, autonomy, alignment, and responsibility, so they're essential for building AI agents that can operate effectively in complex environments. So these three principles, autonomy, alignment, and responsibility, are essential for building AI agents that can operate effectively and in complex environments. By embedding and using these principles into our design and development process, especially for your homework this week, we ensure that AI systems are reliable, ethical, and aligned with user expectations. And later we'll see how to do that with Swarm. I don't know if we'll touch on Crew AI, but we can do a brief intro siguro on one of our videos as well. Great. So let's touch on the five components of the agentic framework really briefly. So it consists of five core components, namely perception, reasoning, action, learning, and ethical governance. So perception is the ability of the AI to gather and interpret data from the environment. For example, yung example natin kanina about autonomous cars using cameras. So they use cameras, LiDAR, and sensors to detect road conditions and obstacles. So they can perceive their environment around them. Next, reasoning. So logical, goal-oriented decision making. For example, if you have a navigation AI that calculates optimal routes considering traffic, road conditions, and fuel efficiency, this would be a form of reasoning, right? Because it shows you this decision making. You can also see this in some LLMs when pinaprint mo yung entire output nila or how they're reasoning. So you can see logically how they go from each step to the next step and why they made that certain decision. Third, we have action. So this means executing decisions in real world context. So this includes precise control and adaptability, such as kunyari, if you're using robotics or building something in robotics, you could have a robotic arm in manufacturing or responding to dynamic conditions. So this is basically ensuring that the decisions that the AI make are precise and adaptable as well. Right? So kanina we talked about how some traditional systems are more rule-based. So eto, adaptable given the context that you have in the moment. The next one is learning. So systems improve over time by incorporating new data or feedback. This is also where we can include the human feedback potentially when we're building out a whole product. So, for example, fraud detection algorithms can refine their patterns based on newly flagged cases, right? And last but not least, ethical governance. So this means embedding ethical, legal, and societal norms into the system design. For example, especially in healthcare. So healthcare AI must comply with privacy regulations like HIPAA, which is more common in the States, or whatever regulations we have here in the Philippines in terms of patient privacy, while ensuring fairness and diagnosis. So now that we have these five components, these together ensure that the AI systems that we build are capable, adaptive, and governed by ethical principles. So, why exactly should we use the agentic framework? What are the main benefits? What are the key benefits of using this specific framework? So, therefore, enhanced efficiency, improved decision making, adaptability, and building user trust. I think a lot of these are pretty self explanatory. So, papasadahan ko na lang. But first, in terms of enhanced efficiency, this means automating repetitive or complex tasks, which can save a lot of time and resources. So, for example, a lot of the admin work, pwede nating gawing separate na AI agent, right? So, for example, logistics companies can also use AI to optimize delivery routes, reducing costs, and improving reliability. So, we saw some of you building projects related to this 2 weeks ago when our topic was related to logistics as well. The second is improved decision making. So AI analyzes vast data sets to identify optimized solutions. Predictive maintenance and manufacturing, for example, can reduce downtime by identifying issues before they occur. Right? So we're able to make decisions proactively instead of reactively. And then third, adaptability. So AI systems built with this framework can scale and evolve across different domains. For example, a natural language model trained on customer service can adapt to multiple industries with minimal retraining. Or kunyari, could even adapt to different languages or different countries with multiple retraining, as we've seen in the past, with minimal retraining, as we've seen in the past few classes. And then last but not least, so building trust. Transparency and accountability mechanisms can foster user confidence and also help us ensure that we're building ethically. So, for example, an AI powered hiring tool can help explain its candidate scoring process by building trust by making decisions auditable. Right? So, instead na bibigyan ka lang ng score, it actually explains why it gave you that certain score, which integrates the ethics and the trust into what we're building. So now kind of just a few examples where we can apply this agentic framework and where we see it in the real world. So this framework can help support AI systems in healthcare, autonomous vehicles, smart cities, and customer service. So for example, healthcare, AI diagnostic tools can analyze patient data and recommend treatments. Actually, super funny because I was talking to one of my friends who is a doctor, and he's one of the guys who I build a lot of like tools, products, projects with. And he was just telling me how truly transformative yung agentic framework was for him as a doctor. Na parang ang dami daw niya naiisip na pwedeng i-build using agentic framework na offload yung mga admin work niya so he can focus on the work that only he can do as a doctor as compared to yung mga admin stuff, right? So, yung, for example, yung booking ng patients, yung mga reseta, and all of these things, right? So, yeah. So, for another example here is IBM Watson. So, IBM Watson can actually assist doctors in identifying complex conditions based on historical data. Another example in the autonomous vehicle area is Tesla's autopilot. So, for example, this does use AI for real time navigation, obstacle avoidance, and traffic adaptation. I also had a friend before, she was working at Uber and she was working on the autonomous vehicle kind of project team. So, she was talking to me about exactly how they were using AI and the principles that we discussed earlier, how they were applying it in her job. So she was a full stack engineer on the autonomous vehicle team within Uber. The third one is smart cities. So AI can optimize energy distribution and traffic flow in urban environment. For example, Singapore uses AI to manage its transport systems efficiently, something that I kind of wish we also had here in the Philippines. And last but not least, customer service. This one is probably the most popular one and the one that people are more familiar with. So, virtual assistants like chatbots, which we built last week, can handle customer inquiries at scale, and this can also reduce response times while maintaining consistency. Great, but what are the challenges related to this framework, right? So, despite all of the strengths that we talked about, despite how exciting it is to kind of be building in this area and having, this type of access to multi agents or multiple agents, there are still several challenges to the agentic framework. So the first one is complexity in design. So how exactly do we balance autonomy with human oversight, right? So this is a non-trivial question, and I think this is an area of current research and just an area where people are currently building out solutions still, right? So a popular example that people use is autonomous drones. So these, for instance, must make independent decisions while adhering to air traffic regulation. Especially when you're using AI for national defense, pumapasok din tong issue na to in terms of design complexity. And related to our second point, ethical dilemmas, right? So you could have bias in training data, which could lead to unfair outcomes. I know we talked about this in detail in our third lecture, so I won't dwell too much on this. But another example is, hiring, right? So hiring algorithms can inadvertently favor certain demographics if trained on biased historical data. Same thing for image recognition or facial recognition algorithms. The third challenge we have is regulatory compliance. So, navigating global AI regulations such as the GDPR in Europe or sector specific standards like what I mentioned earlier, HIPAA for healthcare in the States, requires a significant effort. And last but not least, resource requirements. So high computational and developmental cost can actually limit the accessibility to the of these AI agents or AI tools to smaller organizations. So for example, training large language models often requires immense compute resources, making them impractical for some use cases. Right. So it's interesting because yes, while there are high resource requirements, that's why we have a lot of people who just use pre-trained models as compared to training everything from the ground up, right? So these are some challenges to the agentic framework as well. Awesome. So what does the future of the agentic framework hold? What does the future hold for us, right? So we have a few key points for you to consider, not just in this class, but as you continue building with AI and agentic frameworks. And these are first hybrid intelligence. So how can we combine human and AI decision making? For example, if we're looking at radiology, right? So how can AI act as a second opinion for doctors, enhancing diagnostic accuracy? Second, ethical AI ecosystem. So, how can we implement the widespread adoption of ethical standards across industries? I know that here at AI Republic, we're actually trying to build that out for the Philippines. So, definitely watch out for that as well. But we see companies like OpenAI and Google are already emphasizing, or they say they're emphasizing responsible AI practices. And of course, multi-agent systems, which is what we'll be tackling today. So AI agents which collaborate to solve complex problems. For instance, we can use autonomous drones that work together to deliver aid and disaster relief. Or even just later today, we can see how we can have multiple AI agents pursuing or doing your SEO campaign all within Python, right? Using Swarm. And then last but not least, AI for social good. So applications targeting global challenges like AI models optimizing renewable energy usage or tracking deforestation through satellite data. Right, so that was a quick introduction into the agentic framework. And now we'll actually move on to our next deck for the day. Okay, great. So before we dive into the code, let's go over a brief background and introduction into OpenAI Swarm. So, as mentioned earlier, this is relatively new. It's actually an experimental framework that OpenAI designed to facilitate the development and orchestration of multi agent AI systems. And this is really transformative and pretty cool because it allows developers to create specialized agents that can collaborate, can hand off tasks, and execute complex workflows autonomously. It really shows us kind of like a shift in how AI can be used because we're moving beyond just having like one agent or single agent models. And now we have a more dynamic and cooperative system made up of multiple agents. So one way that we can actually think about Open AI Swarm is as a team-based approach for AI. So just like how humans, just how like we all specialize in roles and collaborate on tasks to achieve efficiency, which I'm sure those participating in the hackathon would know because we discussed earlier what are your competencies, what would you like to work on. So Open AI Swarm also allows AI agents to specialize and work together seamlessly. For example, in a customer service scenario, one agent might handle general FAQs, another one might handle technical escalations, and yet another might process billing inquiries. So, together, when you put these different agents together, they're able to form a cohesive system that can then handle tasks far more efficiently than a single agent. In this set of slides and in this lecture today, we'll actually cover what OpenAI Swarm is and why it's important, how does it work, what does it mean it has a collaborative approach, what are some key features like multi-agent collaboration and modularity, and what are some ways that it can be used in different industries and how you can get started. So we'll do that before we go into the coding session later. And just like a quick note, and before we kind of dive into more Swarm, just I wanted to share a chat dev. I don't know if we've shown you this before, but just wanted to help you visualize what a multi-agent system kind of looks like. So here they have this cute like anime style design, but basically like you have each of these agents doing a task or set of tasks that they're good at, right? So you have agents who are designing, you have agents who are coding, then you have agents who are testing, documenting, so on and so forth. And then in the middle, you kind of have this orchestrator agent or this, manager or coordinator agent who's kind of in charge of overseeing the workflow, breaking down complex tasks into smaller subtasks, and then delegating these subtasks to your more specialized agents. Right. So I just wanted to show you that so you get a visual of what a multi-agent framework looks like, and we'll do this in code later on. So, OpenAI Swarm is actually built on four core ideas, namely collaboration, efficiency, scalability, and transparency. So, first, in terms of the collaborative approach, the key idea here is that the agents in Swarm or OpenAI Swarm can work together, right? So, collaboration allows these agents to break down complex tasks into smaller, manageable components. So, for example, if you want to simulate a warehouse logistics, one agent might manage inventory levels, another agent might optimize delivery routes, and another might oversee maintenance or scheduling. And I guess on your own, you can think about other tasks that you can assign an agent to do in that, logistics kind of industry, right? So this division of labor makes the system a lot more efficient. Now, instead of having just one agent trying to do all of these multiple things and being good at all of these multiple things, you actually have more specialized agents that are collaborating together. So the second one is efficiency, right? So as mentioned, by working collaboratively, agents reduce bottlenecks and improve resource utilization. So imagine a financial workflow where one agent verifies documents, another assesses creditworthiness, and the third one finalizes loan approvals. So instead of handling these steps sequentially, Swarm enables parallel processing, saving time. Actually, it almost sounds like the specialties that we could have, like working at the bank or that we could have working at the financial institution. So basically, like assigning certain jobs to an agent, right? Something that you'd want them to be the most efficient at. Third, we also have scalability. So Swarm's modular design allows developers to add or remove agents as needed. So this flexibility ensures that the system can scale to handle increasing complexity. So for example, in the retail industry naman, we can look at that industry and see like maybe adding a new line of products might only require adding a new agent to handle product specific recommendations, right? So we might need agents in the beginning, but then as our team grows or as the product that we're building kind of expands and evolves, baka hindi lahat ng agent na we created in the beginning, we might not need all of them again, right? So it's easier to develop in that sense because you can just kind of pick and choose which agents you want. And then if there's one agent that you'd like to improve or that you think you want to make more efficient or work on, you only need to work on that agent versus working on the entire framework or architecture or system, right? And then last but not least, transparency. So as an open source framework, OpenAI Swarm fosters community engagement. So I'll show you in a bit, but it's literally completely open source. It's actually on GitHub. Then you can see sobrang recent din ng mga commits and mga PR on there. So developers can contribute enhancements, propose new features, and share real world use cases. This ensures that the framework evolves to meet diverse industry needs. And ang cool din dahil because it's on GitHub, you can actually make it work with your own LLM or whatever you want, right? Or build onto it, add features because the whole code is on GitHub. So let me just show you how that looks. So this is the link to their GitHub repo. You can actually see all of the commits. It's pretty recent, last month lang, diba? So it's intended to be experimental and educational. And as mentioned here, and I'll talk about this in a separate slide, but they have a really nice cookbook or paper that discusses what it means to orchestrate agents, right? So it teaches you how to install and so on and so forth. And syempre, it reminds you not to use this in dev or not to use this in production. Sorry, not to use this in production rather. Yeah, and it's these are some of the reasons why OpenAI mentions that Swarm has a lot to offer. So it's lightweight, scalable, highly customizable, and then the documentation is also really good. There's a lot of examples that shows you how to use it. It also tells you kung ano yung itsura ng architecture and it all has like white papers as well, right? So it really describes what you need to get started on this. And I know we discussed this earlier, but it's just nice that they redefine what an agent is. So according to OpenAI, an agent simply encapsulates a set of instructions with a set of functions plus more settings and has the capacity or capability to hand off execution to another agent, hence the collaborative nature. So if you dive further into the documentation, it also tells you, code samples, how you can provide instructions. So what are instructions? So these are directly converted into the system prompt, which I know we studied over the past few weeks. So it's converted into the system prompt of a conversation and only the instructions of the active agent will be present at any given moment. Right? So sobrang descriptive din ng examples nila dito as well as how to integrate functions as well, how to do handoff, which we'll see later, and then yung mga schemas and so on and so forth. Right? Okay, so going back to our deck, so what are some of the key features of Swarm? Right. So diving deeper, we have here multi-agent collaboration, modular and lightweight, and yung open source community. So what does this mean? Right. Yeah, so going into the key features, so first, multi-agent coordination. Swarm really enables multiple AI agents to work together, as we've discussed, and it breaks down tasks into subtasks that can be handled by specialized agents. Another example is, maybe if we're doing sales, right? So one agent might manage sales while another handles refunds. And then you could even have something that you call a triage agent, which directs queries to the appropriate specialist. So it's similar to yung parang agent in charge or manager agent, parang ganon. So next, yung lightweight and modular design. So the framework is built for simplicity and ease of use, which really allows devs to create and integrate agents with minimal overhead. And we'll see later in the code na it's actually only a few lines of code to create an agent and to put them all together and to implement a multi-agent framework. So this modularity makes it adaptable for various applications from customer support to data management. We also have task handoffs, right? So agents in Swarm can seamlessly transfer responsibilities to one another, maintaining context throughout the process. So that's one of the big keys, right? It has context. So this capability enhances efficiency and allows for more complex task execution over extended periods without continuous human input as compared to yung mga before na ginagawa natin that would require probably a lot more human input. Now, paunti ng paunti yung human input. Although, hindi naman siya completely mawawala, syempre. And then, of course, yung open source community and then educational and research focus. So, OpenAI has positioned Swarm, as mentioned in their GitHub, as a tool for experimentation and learning rather than a fully supported product. Kaya sabi nila na wag nyong i-deploy sa production, right? So, it serves as a cookbook for developers interested in exploring multi-agent orchestration. Great. So I think we've talked about this in detail earlier, but just briefly, right? So why should we choose to use OpenAI Swarm? So looking at this, we actually have a few features and we want to better understand how OpenAI Swarm compares to some of the other things that we've learned in class, namely custom GPTs, API assistance, and API functions. So there are four kind of metrics that we're looking at. So collaboration, scalability, task complexity, and delegation of tasks, right? So how does OpenAI Swarm compare and why does it make a difference? So, for example, in terms of collaboration, Swarm enables dynamic coordination between agents, between multiple agents, which is critical for solving multi-step workflows. Before yung mga standard single agent systems, they kind of handle tasks in isolation, right? So it's kind of a big difference. Now you have dynamic coordination. In terms of scalability naman, so Swarm is designed to scale effortlessly, right? Even just how it's set up in terms of modularity, so on and so forth, how you can work in with parallelization. So adding new agents is pretty straightforward, and this allows for increased complexity without having to redesign the whole system. Next, in terms of task complexity, so while most of the other frameworks handle moderate tasks, Swarm really excels and is really good at managing multi step and highly interconnected workflows, right? So, especially when you're not sure what step goes before another, right? Because before, like you're able to kind of say in a graph step one, step two, step three, step four. But then with multi-agent, you can kind of go back and forth, diba? So parang nagbabago yung steps depending on the context. So for example, simulating a supply chain involves forecasting demand, managing inventory, optimizing deliveries, and then monitoring customer satisfaction. So all of these are roles that Agent and Swarm can handle collaboratively. And of course, delegation of tasks. It's only possible now using Swarm. So now you have dynamic handoffs between agents. So, what are some practical applications of this? So, first we have task automation. So, larger tasks are able to be divided into smaller subtasks, which enables specialization and efficiency. For those of you who are really into econ, you can kind of see how this like works together, right? So, for example, in a software dev pipeline, one agent could handle code analysis, another could perform testing, QA, another could manage deployment. So, parang hinahati-hati mo talaga yung mga tasks. The second one is scalable solutions, as already mentioned earlier. Because Swarm is so adaptable, it really shines in dynamic environments. So if you have an e-commerce system that experiences a surge in demand, new agents can then be added to handle tasks like inventory updates or personalized recommendations. So madali lang mag-add or magtanggal ng agents, and you'll see that in the code as well. And last but not least, multi-agent simulation. So Swarm is particularly suited and good at scenarios requiring agent interactions, such as modeling traffic patterns in smart cities or managing robot teams in a warehouse. So, what are some of the benefits of Swarm, right? So, for developers, it really simplifies yung system design and then encourages us to innovate. Because, in my opinion, parang nade-democratize talaga yung application ng multi-agent, right? Just because like the code is so similar to how we code just with the general like open AI framework already. Now, if you're integrating Swarm with that, like the code is pretty readable, the documentation is also really good, and then you can test a lot and like orchestrate a lot of agent interactions. For businesses, on the other hand, you can have more dynamic and efficient handling of large scale operations. If you want to automate a lot of workflows, it's also helpful, as mentioned, because of the fact that you can have a lot of agents, and it really helps in terms of resource allocation. Instead of having a person doing a like repetitive admin task, baka pwedeng agent na lang, 'di ba? And putting all of those agents together. So next, so getting started with Swarm. So how exactly do you get started with Swarm? So setting up. So you can actually download the framework from GitHub, the one that I showed you earlier, and we'll do this in our live session. And then in terms of design principles, just think of each agent as a specialist, as we've been talking about. So define their roles and responsibilities clearly, and ensure that you do that in the prompt as well. And yeah, for example, if you have a coding system, you might have one agent who specializes in syntax errors, and then another optimizes performance, a la lead code memories, right? And then, of course, think about workflow design. So you can plan how agents will interact and delegate tasks, and then you can build workflows that enable seamless collaboration while avoiding redundancy, like agents that are repeating what another agent is doing. So real world use cases, I feel like we've talked about a lot of examples earlier as well, but just to kind of hammer the point down, so you can have real world use cases of these in customer support, in healthcare, or even in finance, right? So on customer support, multi-tiered support can be automated with agents specializing in FAQs, technical support, and billing inquiries. For healthcare, agents can optimize workflows, handling tasks like appointment scheduling, like what I was saying about my MD friend who is also into AI, managing medical records, another big pain point for doctors, and monitoring patient adherence to treatment. So, kunyari, are they taking their meds, yung mga reminders, so on and so forth. Financial services, so multi-step loan processing, especially pag nagpapa-approve kayo ng loan. So this then becomes streamlined with agents verifying documents. Yan isa pang sakit sa ulo, diba? Document verification, assessing worthiness, and finalizing approvals. So community engagement, I feel like this just goes to show that Swarm really thrives on community contributions. And yeah, we just highly encourage you to kind of contribute to open source if you haven't already, right? So you can collaborate with devs worldwide. You can share use cases, propose enhancements, contribute new features, and who knows, maybe you can even get hired, right, by contributing to their repo. And then yeah, you can try to fork the repo, build your own agent, and submit pull requests. So this collaborative spirit really ensures that Swarm remains at the forefront of multi-agent AI innovation. And so, last but not least, to conclude, so OpenAI Swarm is really a transformative and powerful tool for building the future of AI systems. So, whether you're working on workflow automation, simulating complex environments, or scaling dynamic solutions, its flexibility and collaborative capabilities make it an essential framework for modern AI engineering. And even though bago pa lang siya, ang dami ng good reviews and good feedback, and ang dami na ding nag integrate and gumagamit ng Swarm. So, yeah, excited to explore it with you guys later today. Well, I guess tomorrow because I'm filming this on Friday, but like later today, and yeah, do the code exercises with you as well. Awesome. So before we move on, just wanted to spend a bit of time and just like a little bit of background on routines and handoffs. And this is largely from this cookbook article by OpenAI, or you can find it on the OpenAI cookbook. And it's really like the background on Swarm. As you can see here, they mention that Swarm is actually a sample repo that implements the ideas in this like cookbook entry, namely routines and handoffs. So just wanted to spend some time chatting about that before we dive into the code this afternoon, and before we go into getting your API keys and all of these. Great. Yeah, so we're gonna explore orchestrating agents, routines, and handoffs, and this is basically a framework designed to manage complex interactions between AI agents, as we've already seen. So this approach introduces two critical concepts: routines, which provide structured workflows for agents to execute tasks, and handoffs, which allow seamless transitions between agents when tasks require specialized skills. So why is this important, and why do we want to spend a bit of time learning more about this? Right. So as AI systems grow in complexity, and as you build later on today, single agent models often struggle to handle multi step or specialized tasks efficiently. So, when you orchestrate these multiple agents, you can actually make your product or your AI application a lot more scalable. So, it can be more scalable, more flexible, and modular, as we've seen earlier. So imagine building a customer service chatbot where one agent again handles, FAQs, another processes refunds, and a third does troubleshooting, which is kind of the example that they go through in the article with code as well. So I highly recommend, if you have some time, kind of just look at that and see how they implement and execute their code in Python. Right. So a few of our goals today are just first to understand how routines provide structured task flows for agents. Second, to explore how handoffs enable collaboration between agents. Third, dive into how to implement these with maybe a few brief examples. And then, of course, fourth, discuss the benefits of this framework and how we can adopt it in our AI workflows and how we actually see it in Swarm. So let's start by looking at routines. So as mentioned earlier, routines are really just step-by-step guides for agents to complete tasks. You can think of them as predefined workflows that structure how an agent operates. So we start by defining the steps. So routines break down tasks into manageable steps. So for example, a routine for booking an appointment might include first collecting the user's preferred date and time for the appointment, second checking the availability in like a calendar system, like a when to meet type thing, and then third confirming the booking and sending a notification. The second part of this is leveraging tools. So agents use external tools or APIs to execute different parts of a routine. So for example, a weather chatbot might call on a weather API to fetch forecast data. And these tools really enable us to extend the agent's capabilities beyond simple text generation. Finally, we have flexible execution. So routines handle conditional logic to adapt to dynamic inputs, which we've already talked about earlier. So for example, if a user says, I want to book a flight, the agent might ask from which city or to where, right? And follow different steps based on their responses. Again, the key advantage of routines is their modularity. Because of this, you can design specific routines for each task, really ensuring that agents perform more efficiently and more consistently. So specific to LLMs, let's break down exactly how routines are executed in systems that use LLMs. So first at the top we see user input. So the process starts with user input such as book me a table for the night. For example, you want to be able to book a table for you and your friends to have dinner, right? And then we get the model response, right? So the model response is when the LLM generates an initial response using the routine, system instructions, and context. So those three things: routine, system, instructions, and context. For instance, your LLM or your model might respond with, "What time would you like the reservation?" And then third, you have tool calls. So the agent might call external APIs or tools such as a restaurant booking API to fetch or process data. And next, you have function execution over here. So the results from the tools are integrated, and if the restaurant API, for example, confirms availability, the function might return details like a table is reserved for 4 people at 7 p.m. And then finally, you have model updates. So the LLM updates its state, and I think if you look into LangGraph, you can also see they also mention state in their framework and in their architecture. So the LLM updates its state with a tool's output and then continues the conversation. It might confirm the booking and provide further assistance. So basically, as you can see, it's kind of an iterative approach, right? So this iterative approach really enables agents to dynamically interact with tools, execute functions, and then adapt given the user's needs. So next, let's discuss handoffs briefly. So what are handoffs, right? So handoffs are a key mechanism that really enables agents to collaborate. Um, an agent handoff basically allows the system to switch between agents dynamically. For instance, the triage agent that we mentioned earlier, this one can determine if a user has a billing issue, then it can transfer the conversation to a refund agent. Basically, siya magde-decide kung aling agent ita-transfer yung certain query or concern given the user input, right? The next one, we have context preservation. So when the handoff occurs, all the prior context, so kunyari ang mga conversation history mo, yung state na tinawag natin kanina, task state, all of this is transferred to a new agent. This ensures a seamless user experience as the new agent doesn't need to ask redundant questions, right? So, kung sa customer service nga, nainis tayo sa redundant questions, sa agent pa kaya, di ba? AI agent. So here, it actually is able to preserve the context. And then third, enhance flexibility. So handoffs enable complex workflows. You can design specialized agents for different tasks, such as one for troubleshooting and another for upselling. So these agents dynamically collaborate to handle your user needs. And how exactly do we implement this, right? So we'll see this more clearly in the code later, but just wanted to kind of share what classes you'll see, for example, or what functions you'll see a bit later. So there's a few key steps. So the first step is really having or implementing an agent class. So each agent is encapsulated in a class which specifies its role, tools, and instruction. So dito yung pag-define natin ng class. Let me see if I can actually find an example. So here, based on the documentation and the AI Open AI cookbook, you can see that we can start by defining a basic class for an agent. So this is how an agent class looks like, right? So gives you the name of the agent, the model, the instructions or our prompt, right, and any tools that we might want to use. Next, we have transfer functions. So these are methods within an agent that indicate when to transfer control to another agent. Diba? So kailan mo i-hand off. So for example, a function might return quote-unquote handoff to sales if a user's issue is sales related. And then third, dynamic agent update. So the system must support real-time updates to switch agents based on transfer calls. This might involve updating a shared state or reinitializing the conversation loop with a new agent. So dito pumapasok yung anong state, ano ba yung current state ng agent and ng system. So how does this look like and can we dive deeper into an example? So for example, if we have a customer service agent, right? And just starting with no code for this discussion this morning, but of course we'll see this implemented in Python later today. Right. So let's look at this concrete example. So first, you can have a triage agent, and your triage agent will be the one that gathers initial information and decides whether the user's issue is related to sales, refunds, troubleshooting, buying a new product, so on and so forth. Diba? So basically siya yung parang decision maker agent. Next, you can also have a sales agent. So yung sales agent mo can handle purchasing related inquiries such as pricing or product recommendation. So if may mga tanong yung user mo about certain products you have, magkano, may sale ba, so on and so forth. So this can be given to yung sales agent. And so next, we also have a refund agent, and this one can manage requests and return-related issues. So, kunyari, pag magpapa-refund yung customer nyo, so dito dadalhin yung mga queries about that. Kasi iba din siya yung process. It's not the same as sales. So, it's a different agent for a different job. And then lastly, you could potentially have an issues and repairs agent. So this one naman can help you troubleshoot product problems or initiate repairs. So, kunyari, bumili ka sa Lazada ng something, tas di pala siya gumagana, diba? So recently, I just bought like a water fountain for my cat and it's not working. So, dun ako ma-direct sa issues and repairs agent because that's the one that's more appropriate to, what I need and their specialty. So yeah, if a user starts with, for example, I want to return my product, then the triage agent will hand off the conversation to the refund agent seamlessly, right? And depending on where the conversation goes, mas madali na yung handoff na yun kasi modular yung agents natin. Great. So, what are a few benefits of routines and handoffs? A lot of these we've already seen earlier, but just to kind of hammer the point. So, improve scalability, enhance flexibility, and increase maintainability. So, what does that mean? So, improve scalability. This means now we can add new agents and routines without affecting the existing system. For example, if we want to add a subscription management agent to a customer support system, gaya ng kanina, this would be straightforward, right? Maybe you have a subscription like Amazon, right? Like you can go shopping, and you also have customer support needs, and then you can just add a new subscription management agent on top of all of your other agents. Next, enhanced flexibility. So handoffs allow the system to adapt dynamically to user needs and, of course, understand as well the context, enabling seamless transitions between agents. And finally, increase maintainability. So agents and routines can be updated or replaced independently, reducing development overhead and making the system easier to manage, right? And this again is because of their modularity. Great. So now that we've seen that, we're actually gonna go into looking at Swarm later on, and really I mean, I know I've mentioned a lot of points here. They might sound like similar, but mas makikita nyo talaga sa code demo. So hang on for our, I guess, hands-on later this afternoon, right? So we can OpenAI Swarm is one of the ways that we can explore this orchestration framework, but there's also a lot of other ones. So there's Crew AI, there's also LangGraph, and maybe like we can link a few other ones in our Discord, but those are the ones that I feel like are pretty popular. And yeah, just like how they're implemented within each framework or orchestration method is somewhat slightly different, but it's still the same core concepts. And just to add, no, I would say so that you kind of see the impact and the effect of this, and it doesn't get, too confusing or too overwhelming. You can start by defining a simple workflow with just like one or two agents, and then expand it as you get more comfortable with routines and handoffs, and just like the whole orchestration and like agentic framework. Okay, great. So now we're moving on to Firecrawl. So as you all know, one of the important parts of building any just AI application is making sure that we have the right data. So what we'll be using today to get that data is something called Firecrawl. So Firecrawl basically allows you to turn websites into LLM ready data. So it's an API service that enables and allows users to scrape and crawl websites, converting their content into clean LLM ready formats such as Markdown or structured data. So, this functionality is really beneficial for AI apps, especially those that require web data for training or information retrieval. So who is this for? So it's for devs, for data scientists, digital marketers, and researchers. For AI developers like us, we can get clean, structured input for our AI models. For data scientists, it can automate the collection of web data for analysis. Actually, much easier than a lot of the other web scraping tools that I used before. And honestly, like it's easier than I don't know, like manually scraping a website using Beautiful Soup, for example. It's also helpful for digital marketers to conduct competitive analysis and then aggregate content. And finally, for researchers so that they can collect information at scale more efficiently. So, what are some of the core features and really like the benefits of Firecrawl? Right. So, some of the key features of Firecrawl include, well, of course, first scraping and crawling. So, Firecrawl can extract data from individual web pages or crawl entire websites, retrieving content from all the sub pages. Right. So, it's kind of similar to how Cursor is able to search all of the sub pages within a specific repo if you create a doc with it. So here you can access all of the sub pages without the need for a sitemap. Next, there's also dynamic content handling. It effectively manages websites that utilize JavaScript to render content, ensuring comprehensive data extraction. And then, of course, output format and URL mapping. So the API provides data in various formats, including Markdown, HTML, raw HTML screenshots and links, which really caters to a diverse set of application requirements. So no matter what you're using your web scrape data for, it can actually output it in that format that you need. And then of course integration with tools. So there Firecrawl has a bunch of SDKs for multiple programming languages, including Python, which we'll be using today. And then it facilitates seamless integration into existing workflows. So here's some examples of the API endpoints that you can use with Firecrawl. So first you have scrape. So your input here is just one URL, and then the expected output is content in either Markdown, HTML, or whatever format you'd want it. Next you have the crawl endpoint. So here you want a base URL, and then it will give you all of the data linked from all the link pages within the same domain. So yung mga sub pages, for example. Next, you have map. So here you want the website URL, and then its output will give you a list of all accessible URLs for structured crawling. So for this, you can actually also view these API endpoints on the GitHub repo. So this is the GitHub repo of Firecrawl. It's actually completely open source, which is awesome. It's under the AGPL 3.0 license. And the documentation is pretty robust, right? So there's API documentation, and these are the features that we just talked about, right? So it's actually pretty easy to kind of click into one feature and then, for example, like see how it's implemented, right? So, for example, crawling, you can use this to crawl a URL and all uh, accessible sub pages, and this is what it does. This is how like the curl will look like, how the request will look like, and this is supposed to be what it will return, right? So it returns a crawl job ID and the URL to check the status of the crawl. Um, Here's a sample response from the scrape endpoint that we just talked about earlier, right? So we will need an API key, which if you haven't done it yet, I'll show you in a while where to get it. Honestly, it just shows up like after you sign in, so it's pretty easy. But this is an example of how a response looks, right? So you have metadata, description, you have keywords also, and information about any images you have on the website and the source URL. If you use the map endpoint, on the other hand, this is how a request would look, how a post request would look, and then this is the response, right? So you can kind of see that it's used as a map to it's used to map a URL and get all of the URLs related to that website. So for example, firecrawl .dev, it looks at all of these like links and like sub pages related to that, and our input was just this one, right? So apparently they also have this cool new thing which is map with search. If you add a search parameter, you can search for specific URLs within a website. For example, I just want to see like docs or documentation. You can add this parameter search, search for docs, and then you only get the results that are most relevant to these docs, right? So here you can see all the SDKs, learning, RAG, and Llama. Awesome. So yeah, all of this is open source. I'll link this in probably just in the materials that we'll provide. And yeah, going back to our slides. So these are examples of some API endpoints, and as mentioned earlier, you can actually integrate it with SDKs. So there's a Python SDK, a Node.js SDK, and Go and Rust. I feel like the one that's more relevant for us today is Python, just because that's what we'll be using in class. So this is really ideal for data scientists and ML workflows, and of course, AI, LLM building, and AI agentic stuff as well. Um, Cool. So how do you get started? I'll show you kind of how to do it, but basically you just sign up on the website. You can actually use your GitHub or your Google account to sign up or sign in. Then you can install an SDK, pick what programming language you want, use your API key to initialize the SDK, and then yeah, just begin your workflow. There's also a bunch of plans. I think for us, sobrang kaya na ng free tier for our plans. But there's also pro and enterprise as well. So again, this just really depends on like how many API calls you have. So why use Firecrawl? So mainly because of these four key reasons, right? So efficiency, flexibility, scalability, and simplicity. Efficiency, it automates time-intensive web scraping and crawling tasks. So I remember before when we'd web scrape, it would be like a whole project in and of itself, right? And now you can literally just like link a URL. Actually, even on the website of Firecrawl without logging in, you can sample and then just link a URL that you'd want to scrape. So here's the Firecrawl website. You can see like it gives you a bunch of examples, and these are a lot of the companies that are using it. And yes, there's Node, Python. There's also like directly the curl command. And I think for today we'll actually be using the Python implementation. So yeah, even without signing in, you can actually get started with a few free credits. For example, I want to scrape the CarMax website, right? So let's see what happens. So it actually, and this is yeah, so this is getting the code. We can actually get the code and see how it's implemented, and this is where your API key is. It gives you the code on how to scrape that specific web page. I guess I'll just block out my API key or like blur this out later, but yeah, it'll show you what you can use to plug and play, and also yung nire-return after you do the API call. So So this is the output for that specific page, and this page kind of, I mean, there's not too much on it, so let me just show you how it looks. But yeah, this is like the just the home screen of the CarMax page. So it's basically just information about all these cars. So how does that look when we scrape it? This is the markdown, right? This is the markdown. So get the quote, all of the text, right? All of the information about the cars. Pretty interesting. But you can also get it as a JSON response. And what's nice about this is it's like easy to kind of copy paste everything. And then I'll show you how we can do it on another website. Okay, so say I want to crawl the Y Combinator website. If you actually click this drop down menu, you can also you can also get a few options. So you can limit the number of pages to crawl. You can exclude certain paths. For example, you don't want to include their blog. Max depth, so this is max depth to crawl relative to the entered URL. And if there's only paths that you want to include, for example, I just want to look at jobs, right? So I could include that as well. So you could also ignore the sitemap or allow backwards links. This one I haven't really toggled this too much, but yeah, there's a few other options here. So extract only main content. You can also include HTML content, right? So let's just see what will happen if we include that, and then page links. So for example, if we use the crawl, a while ago we did single URL. Now we're gonna try crawl. So let's just run it to see what we get. Cool, awesome. Okay, this is really cool. Yeah, so it actually tells you how many pages are being scraped, right? And you can download it in any number of however you want to export it. So you can download as Markdown, HTML. You can download just like the links, for example, and then you can also see like the entire JSON response, right? And it does it per page. So this one is for the apply page. This one is for um, apply to Dropbox. This one is, I think, apply to the next batch. But so it does tell you like what specific part of the website it's crawling. And then you can also download everything as a JSON file, right? So it's scraped like a lot in a few seconds, right? So cool. You can also get the code as we saw earlier. And again, I'll just block out my API key for this one. So let's try map and see what happens as well. So we can have these additional options. So there's like a search beta, right? But for this one, I just want to see what happens if I put in just Y Combinator by itself. Okay, cool. So as you can see, we have a total of 372 results, right? And it actually maps it out onto the different sub pages of YC. So it gives us like a site map, right? It tells us ano ba yung mga sub pages under this, and it goes pretty deep, right? So under library, it even checks bookmarks, so on and so forth, right? So ang dami na niyang nakuha as well in a few seconds, and you can also use this as an input to another search if you want. So that's just a brief overview of what you have. So we're in the playground right now within Firecrawl. So I'm already logged in, right? But then you can also view the docs as well. So the documentation is pretty good. They have a quick start, right? Tas yung rate limits, yung pinag-usapan din natin kanina. Some of the features that we tried, there's also an advanced scraping guide, right? So how do you improve your Firecrawl scraping with advanced option for all of these different languages as well. And then yeah, I love also that they have this learn page, right? So it's like basically a series of blogs and tutorials that show you how exactly to use Firecrawl. And there's one nga about Open AI Swarm. So how do you integrate Swarm and Firecrawl together? So I'll just link this in probably in our Discord or in the description as well. Okay, cool. So going back to our short deck. So again, like when you sign in, with GitHub or Google or whatever you choose to sign in with, you can actually just get your API key on the top right. So yeah, so I use Firecrawl efficiency, flexibility, scalability, and simplicity. So Firecrawl in action, it can be used for extracting product reviews. Yeah, and as we also saw earlier, it's pretty easy to use it. So we actually just use the dashboard to try out those websites, but we'll see later in the code how we can use the Python implementation. So yeah, again, hopefully everybody has their API keys and excited to use Firecrawl with you all later. And just a quick reminder, if you don't have your API key, like when you sign up for Firecrawl, it will just be right here. So when you click get code, you can actually see your API key here, and then yeah, definitely will blur this out, right? But that's your whole key. Then you can copy it, and then it'll show you also the code on how to do each one of those API calls that we mentioned, whether it's Python, Node, or curl. Awesome. Just wanted to add also and provide an overview of how just like the dashboard for Firecrawl looks. So here I'm just within Firecrawl. You can see it tells you how many pages we scraped over the last 7 days and how that translates into credits. And again, this is another place where you can view your API key. There's also a bunch of integrations, right? So a popular one is LangChain, and if you go and check LangChain, it shows that you can actually use Firecrawl as a document loader, right? So meron now specific code for using Firecrawl to load documents, which is pretty cool. And yeah, so we were in the playground earlier. Here's another way to kind of get to it, right? Activity logs, it will also show you yung mga na-try na natin kanina, diba? So we tried Y Combinator, CarMax, also example.com. And then yeah, just our usage, right? So how much it costs, the breakdown of our API request. It's actually a pretty robust dashboard, I think. And then if you need another API key, you can actually use this page or use this spot to create another API key. And then you can name it, maybe, sorry, AIR bootcamp as our API key. And then, yeah, here's our new API key. And then you can also delete as well. And yeah, this is just where you can edit your personal settings if you have any team members you want to invite. And if you want to basically use webhooks, although I think this is only for the first version or the zeroth version of the API. So this one is also pretty useful, checking the API status. Just in case nag-down yung service nila, you can actually check if there's a time na nag-down siya, diba? How long it was down. And now, yeah, they're clearly all operational. So that's good. Awesome. So we're actually on our last deck for the day, our last presentation, which is about LLM ready data. So a while ago, we just talked about how we can actually scrape data for LLMs, but what does it mean to have your data be LLM ready, right? So yeah, this term, when you say LLM ready data, this term generally refers to data sets that are cleaned, formatted, and structured specifically to maximize the effectiveness of LLMs like GPT or whatever we'll be using later from OpenAI and so on. So why is this important? So this is important because poor data quality can lead to biased outputs, as we've seen earlier in the course, or it can lead to inaccurate predictions, even hallucinations, or even failed applications of AI. So, for example, if we train an LLM on noisy, unstructured data, it might generate incorrect responses or hallucinate information. So, imagine providing a GPT-4 with a messy web page full of irrelevant ads or yeah, kunyari yung mga like pop-up ads or something, broken HTML and outdated content. So without proper cleaning and structuring, the model will struggle to parse meaningful information. So tools like Firecrawl API, which we just saw, help solve this by extracting, cleaning, and structuring web content into LLM ready formats. So, what are some characteristics of LLM ready data? Right. So we have here four that we'll go into. So we have cleanliness, consistency, relevance, and diversity. So to make data truly LLM ready, it must have these key criteria. So cleanliness. The data should be free from duplicates, spelling errors, unnecessary noise, and for example, this is where we could use something like Firecrawl's scrape API endpoint, which can extract clean, structured data from web pages and remove unnecessary clutter. Next, we have consistency. So data formats need to be uniform. If you're working with dates, for example, those are pretty notorious even in data science, diba? So dates or currencies or measurements, they must follow a standardized format. In terms of relevance, the dataset should align with the domain or purpose of the model. If you're building a financial assistant, the training data should primarily include financial reports, news, and related content. So making sure na yung data na skinrape nyo is actually relevant to the app or tool or agent na you're building. And last but not least, we have diversity. So a diverse data set ensures that the model generalizes well. So looking at Firecrawl, using again the API endpoint they provided kanina. So using crawl this time, we can use this endpoint to gather data from multiple linked pages, ensuring a broader scope of training material. So these characteristics help not just by improving the model performance, but also making the data pipeline more efficient and scalable. So what are some examples of LLM ready data formats, right? So we've seen some of these types of outputs through Firecrawl. Now we can actually export and extract in whatever output we want. So LLM ready data can be structured, unstructured, or semi-structured. So in terms of structure, this means it can include CSV files, JSON objects, or databases, and these formats are especially useful for tabular data or well-defined schemas. Kung unstructured naman yung dataset nyo, this would include something like text files, plain markdown, or raw web content that we just scraped. So the Firecrawl scrape API endpoint would be really good and helpful for converting unstructured web pages into clean markdown or HTML for direct use in LLMs. And last but not least, semi-structured. So we have formats like XML or YAML, which can provide a balance between structure and flexibility. So for example, if we're scraping a website for product reviews, maybe Amazon, the data might be unstructured on the web page. So Firecrawl can then parse this into JSON, which is much easier to work with during training, and which you've seen in our very, very brief demo earlier. So how exactly do we prepare LLM ready data? So we have a few steps that are outlined here. So the first is data cleaning. So this one includes removing duplicates, irrelevant text, or broken links. And for this one, we could leverage on Firecrawl's dynamic content handling, especially when we're trying to extract JavaScript rendered content that a lot of scrapers miss. And even if you do it manually, sometimes you can also miss that. So the next one is data normalization. This just means standardizing formats, such as converting dates into a single format, or ensuring that numerical values have consistent units, right? So if you have currencies, making sure that they're all in the same currency, and then yeah, just making sure that your date times are all correct and accurate. For tokenization, this we've talked about this extensively in our past few classes, but just as a brief reminder, so this is just splitting text into smaller chunks like sentences or words. And for this one, if you guys recall, we can use tools like Hugging Faces tokenizers or Spacey can probably assist here. And we can even use OpenAI for tokenization as well, especially because we're using Swarm today. For annotation, this just means adding labels to the dataset for supervised tasks. For example, if you're building a customer sentiment analysis tool, you might annotate text as positive, neutral, or negative, or whatever other type of annotation you want. Maybe you want to annotate with emotion, so on and so forth. So what's interesting with Firecrawl, specifically for preparing your data to be LLM ready, is that it simplifies the first two steps here, so data cleaning and normalization, by ensuring that the extracted data is clean and normalized, saving significant pre-processing time. So it does this through its API calls. Cool. So now we've reached tools for data preparation. Right? So preparing LLM ready data often requires combining multiple tools for different tasks. So Firecrawl integrates seamlessly into this pipeline as a powerful web data extraction tool. However, aside from Firecrawl, we have a lot of other tools as well. So on the data cleaning side, we have OpenRefine, Pandas, and yeah, as mentioned, Firecrawl. OpenRefine, we use this a lot actually when I was in grad school. This is helpful because it's like a GUI, so you can kind of check and see how you want to, um, you know, like change the formatting of your data, standardize, normalize, so on and so forth. And you're able to keep a copy of all the steps that you took to normalize or refine that data. Right. So a lot of these are often used for manual cleaning, and Firecrawl is like the automated version of this by extracting only relevant, clean content directly from the source. Tokenization, some of the tools we've seen are Hugging Face tokenizers. We've seen Spacey also to pre-process text extracted from our data set. And then for annotation, we have tools like Label Studio or Prodigy, which can be used to annotate the data after extraction. Finally, we have data transformation. Um, so here we can use tools such as Data Prep Kit or the unstructured library. So, what are some examples of LLM ready datasets? So, there are a lot of publicly available datasets that are LLM ready, but some of the ones that we've seen so far are those that are within OpenAI's framework or the Hugging Face framework. So, within OpenAI, we have GPT training data. So, this is text from books, articles, web pages, and basically just the internet, right? And then for Hugging Face, we also have very specific data sets. So, for example, one of our popular data sets is what you call SQUAD. So, this stands for Stanford Question Answering Data Set. And yeah, it's basically a series of questions and answers. So, this one is pretty popular in NLP for doing QA tasks. And originally, it was used widely to train and evaluate ML models that can understand and generate answers from the text. So a lot of the squad data also contains these pairs of questions and answers, and they're based on passages from Wikipedia. Great. So moving on to case studies, how do we actually see the real world applications that demonstrate why this is beneficial and useful to create LLM ready data and use LLM ready data? So our first example is actually S&P Global's Can Show LLM Ready API. So basically, what happened here is that S&P Global's Kensho division developed an LLM-ready API, which is designed to prepare financial data sets for large-scale analysis. This is helpful because large-scale financial data is highly complex and involves vast quantities of numbers, charts, and nuanced text such as earnings reports or even news articles. So, poorly structured or inconsistent data in this domain can result in inaccurate insights, which is unacceptable in high stakes environments like investment management or risk analysis. And just basing on my experience as well, working at a hedge fund, it's really important to have accurate and timely data because any inaccuracy in your data that could either be caused by lack of data cleaning or just the data itself would really affect your analysis. So how does their API work? Basically, their API works by pre-processing financial data sets to ensure that they're clean, standardized, and aligned with the specific requirements of LLMs. Um, So you can imagine a data set that combines the text of quarterly earnings reports with sentiment analysis powered by an LLM. So a clean, well-prepared data set allows models to predict future stock trends based on patterns in language, tone, and key performance metrics. And let me just tell you, this is actually a pretty popular project that a lot of people work on. At least even before the whole age of LLMs, like they were already working on sentiment analysis and kind of using information like quarterly earnings reports to integrate all of that holistically. So, what are the benefits of this, right? So, specifically for Kensho, so financial analysts and researchers gain access to data that's ready to use for tasks like NLU or financial forecasting. And this also dramatically reduces the time spent cleaning and preparing data manually, enabling faster and more reliable insights. For similar projects, we can actually use yung crawl or scrape endpoint ng Firecrawl because we could extract financial data from multiple resources. So, kunyari, mga regulatory filings, financial news websites, investor reports, and possibly convert it into Markdown or JSON to build our own Kensho-like system. So, this then reduces the bottleneck of extracting and formatting data. So for our second case study, we have knowledge graph information. This basically involves integrating knowledge graphs into LLM pipeline. So just as a brief overview, a knowledge graph is a structured representation of facts, entities, and their relationships. So a lot of the time, if you see this visualized, people kind of draw this out as a series or a set of nodes and edges. Adding structured knowledge to LLMs enhances their ability to reason and to make connections. So how does this exactly work, diba? So knowledge graphs are used to supplement LLMs by providing a robust foundation of structured data. So for example, a knowledge graph for the healthcare domain naman could include relationships between diseases, symptoms, treatments, and medications. And when we integrate this into a larger LLM pipeline, this graph then allows the model to generate more accurate and context aware responses. So, a while ago, we talked about the importance of context, right? So, for instance, if a user or a patient will ask, "What are the medicines that I need to take for type 2 diabetes?" Or if I'm always getting, a cold or allergies, what type of medicine should I take? So the LLM then leverages the graph to ensure that the answer is complete and medically valid. So how does this provide benefits? So same as earlier, right? It has improved contextual understanding. The LLM can now retrieve highly relevant information from the graph, even when the input in question is a bit vague. Second, we have reduction in error. So the graph serves as a trusted source of truth, ensuring that the model does not hallucinate. What are some challenges in preparing data, right? Because definitely preparing data to be LLM ready, it's not a menial task. It also requires a lot of thought, and syempre, we really need to prepare for it. So there are three main challenges. So first is volume and variety, second is QA, and of course, ethical considerations. So in terms of volume and variety, collecting diverse language data at scale can be overwhelming, right? So syempre, using Firecrawl, like the crawl function, it really helps us do it much more efficiently, right? But ensuring that we have variety in our data set. Now, we're not just including repetitive data and that we have enough data. So that's also an open ended challenge as well. The second one is quality assurance. So, how do we ensure that the data that we have is accurate and free from bias? This actually requires a lot of careful monitoring as well. And I think it will vary from project to project or org to org. But yeah, just making sure that when we do extract data, it's data of high quality and then doing any additional further data cleaning as necessary. And of course, ethical considerations. So, extracting data often involves removing PII, or what you call personally identifiable information, and or respecting copyright laws, right? So how do we integrate all of these things as we web scrape for our data set? Yeah, siguro with depending on how you scrape your data, we could probably tailor our data extraction process to focus only on the things that we'd want to collect and what's necessary, therefore minimizing the risks associated with ethics, if any. And finally, best practices, right? So, following best practices ensures the success of LLM ready data preparation, right? So, we want to make sure that we are successful in preparing our data set that is ready to be used and inputted into our LLMs. So, first, we have continuous monitoring. So, we want to ensure that we regularly update our data sets with new data, especially in domains where trends change rapidly. So, example, diba, finance, lagi siya na-affect ng news. So, you kind of need fresh news all the time. If you have a logistics data set and you're scraping, I don't know, like a website that shows yung mga tracking, so on and so forth. So, that changes a lot as well. So, continuous monitoring din yon. Next, we have documentation. So, you want to ensure that we maintain metadata about our data sources, including the credibility of our content. So, lagi nga nila sinasabi, garbage in, garbage out, diba? So, we need to understand yung journey ng data din natin, where we're getting it, where it's coming from. Kasi we can do all of the analysis that we want, plug and play into LLMs, but if the data itself is not reliable, it's definitely a challenge, right? So, make sure to document that. And of course, collaboration. So, working with subject matter experts to ensure relevance and quality. So, for example, if you're training an LLM on medical data, collaborating with healthcare professionals would be helpful to verify the content. And so, yeah, with that, today we covered a bunch of topics. So, we covered what are agents, what is the agentic framework, what is OpenAI Swarm, and are there other orchestration platforms similar to that? We also briefly touched on Firecrawl and also saw the importance of routines and handoffs in Swarm. And now, finally, we're looking at how we actually integrate all of these tools and then how we prepare our data set for building out our agentic frameworks. So yeah, I hope this was helpful. Again, if you guys have any questions, let me know. I'm available naman on Discord, or let any of your other instructors know. And yeah, I'll see you all later for Danielle's coding live walkthrough this afternoon. Thank you.